Assalamu alaikum wa rahmatullahi wa barakatuh. This is Ahmed Hegazy, and today, inshallah, we will make this vertical vessel by using SEG software. As you can see on this vessel, on the bottom head, you have a segmental pieces on the bottom head, and each course of the shell courses include 3 welding lines. And if we take a look to the top view, we can calculate the number of segments on the top head, and from here we can get the orientation of the longitudinal welding lines. Here on the support skirt, you can figure that in this skirt we have 3 cans. Here that's the first can length and thickness and material, and for the second can and third can information. Now let's start creating the main vessel items by using SEG software. And in this part, inshallah, we will create the main in this part of tutorial, we will create the main elements of the equipment, like the bottom head, all cans, and the top head and the support skirt. On the other parts of the tutorial, we will discuss the other parts like nozzles and the top davit. After that, we will discuss the internal components like the support beams and some of the external components like the platform clips. Okay, now let's start our project from new. We will create a new project, and from here let's add the vessel name and select the project location, select it and add the desktop, and from here let's select the vertical pressure vessel and select finish. Here by selecting finish, SEG will start creating the project information or the project folder on the defined location. Here we have the vessel name, and now let's edit the equipment setting. Here, as you can see, the position automatically become vertical and start the simply direction from bottom to top. You can define the service, you can change the vessel name from the tag, you can add a serial number. Now let's define the blade length to be 6 meters and the blade width as 1.5 meters here. So from here the available blade dimensions will be automatically used on SEG. We can change this value to 5 meters, okay, because if we take a look to the bill of material here, the maximum blade length defined it as 5 meters by 1.5, so we could change it to 5 meters by 1.5. And now let's click save. Now let's add the first element. If we take a look again here to this bottom head, we can figure that it's an ellipsoidal head per 1 with minimum thickness after forming 22 and nominal thickness 25, and here the straight flange is 15 millimeters. So from here let's add the first head, which is bottom head. Okay, and from here let's select the ellipsoidal head with crown and the macro radius, and from here let's define the inside diameter. It's 3,900. So if we take a look here for that value, we can get the inside diameter for the vessel. So here we define the inside diameter, and here for the thickness, it is the nominal thickness is 25, straight flange is 50, and minimum thickness after forming is 22. And the material of this one, if we take a look here, it's SA, so we can take that value as a copy and paste it here directly, or you can make a search on it like 24 240, so you will get the grades from here, so you can select the grade from here directly from the list, or you can type it from here. This head not a one-piece head, it's include the segments. If you select the second type, you can figure that it's include a single welding line, but when you select more than 2 pieces, you can figure that you can add some segments to the head. Now let's take a look to the top view to calculate the required number of segments. Here we have first, second, third, fourth, fifth. Now we have 9 segments in this head. So from here, let's add the number of segments as a 9, and from here, let's measure the cut length. So let's get the diameter tool, and here the 1450. So let's define that at 1450, and let's define the gap as 0, and the first longitudinal welding line orientation, it's on 0 degree. So we will keep those values like that and click on save. Now when you click on start assembly, automatically SEG will start creating the assembly of the equipment and creating the head assembly as a head from segments. As you can see here, everything run on behind. Nothing appear on the window, but after creating the head assembly, it will be assembled to the final assembly of the vessel. So if you would like to make a rendering for the element during creation, we will make an option give us this ability. Okay, as you can see here, the direction of the head is not on the correct direction. So we need to flip the direction of the head. So from here, we need to select the flip direction. That's the first point. And on the second point, as we discussed, we will need to make a rendering for the elements as a parent or a child during creation. So from here, let's select those options, and from start assembly, let's rebuild the head again to adjust the direction of the segments, okay, to make this head with a flipped direction. Okay, now here this head will be assembled, and now we have this head. If we take a look from the top view, okay, like that, as you can see, the first longitudinal welding line orientation at 0 degree, it will be like that. Now let's add another element, which is the first can. So from here, if we take a look again to the first can, which is that one, it's 1250. Okay, and here we have 3 welding lines, LS101 and LS102 and LS103. Okay, so here let's check the orientation for LS1.1. So let's check the orientation on the top view. It's in at 85 degrees. Okay, and for the second one, it's at 231, and for the last one, which is LS 103, it's on 17. So now let's select the suitable item for that. From elements, let's select the vessel node. After that, select the can, and let's add shell 1. Okay, and from shell 1, let's select from this list, let's select shell from different pieces, which is that item. That item will give us the ability to define the required number of shell blades inside this can. Okay, and we have the ability to control the length of each one. Now let's define the inside diameter of the can. It's 3,900, and from here the height is 1,250, and the thickness is 22 millimeters. Okay, and for the gap we could keep it as it is, and for the material we can copy the material directly from here like that and paste it here. And the number of segments, we have 3 welding lines. So if we change this value to 5 meters and click update, as you can see here, the SEG calculate directly the length of the last one, because we defined the blade length on the setting of the delivered blade dimension option. So from here, as you can see, the length of this first blade become 5,000 millimeters. And now let's define the longitudinal welding line orientation of the first can. It's at 85 degrees. And now when you click on update, as you can see, the longitudinal welding line orientation when the length of the first can is 5 meters length. As you can see, it's 231. So let's take a look here to this one. So the first longitudinal building line is on or at 85 degrees, and the second longitudinal building line, which LS 103, it's at 231. Okay, so that's the second one. So that's the accurate value for the longitudinal welding line orientation. Automatically, when you add the second the length of the second shell plate, the longitudinal welding line orientation for the last can, which is 17 degrees, calculated automatically. Now, as you can see, SEG calculates the actual values for the longitudinal welding line orientation based on the length of each shell plate length and the first longitudinal welding line orientation. Now let's click Save, and from the Assembly tab, let's click on Start Assembly to start creating the first can. Here, as you can see, we can make a rendering for that element during creation, and here each plate will be assembled manually and will be assembled after that with the final assembly of the vessel. Now let's open this can to check the length of each plate. Now for the first part, let's open it like that, and from Get Sheet Metal Development or Get Flat Pattern, now you will be able to measure the length. Here, as you can see, the length of this plate is 5 meters, as we defined on the form. Let's open the second part and check the length of that part. We get the flat pattern, and from the Inspect tab, if you measure that one of this tool, it's 5 meters. So here SEG automatically calculate the third plate arc length based on the inside diameter of the vessel and the thickness of the vessel and the previous parts arc lengths. Here we have the actual length for the first or the last part of this can. Okay, now as you can see, here we have the first can with the longitudinal welding line orientation. Let's add the second can. So from here, from elements, let's add shell 2. And let's make it looks like shell 1 and click on add. Now we have the second shell, and from here let's define the length of the second shell. So let's take a look to the length. It's 1.5 meters. So let's change the value from here, and let's change the first longitudinal welding line orientation for the second can. It's 198. And from here, let's click on Update and Save. And let's add the third can, shell 3, and let's make it looks like shell 2. Okay. And from here, let's change the length and the longitudinal welding line orientation. So from here, the first longitudinal welding line orientation on 93, and click on Save, and the same length with the same thickness. And now let's add the fourth shell 4, and let's make it looks like shell 2, and click on Save. And now when we select it, we need to define the longitudinal welding line orientation for the first can, and click on Update. Now that value is right, and here now it's okay. Let's add another can, which is can shell 5, and shell 5 will be typical to, let's make it looks like shell 3, and from here we will keep those dimensions as they are. And for the first longitudinal welding line orientation, it's on 90 degrees, and click on Update. And now let's click on Save. Let's add can 6, here shell number 6, and let's make it looks like let's say shell 1, no problem. And from here we will need to change the length because shell number 6 is 650, Okay, so we will find it as 650, and for the longitudinal building line orientation we will make it 197 and click on update. Now let's click on save, and for the can number 7, let's make it looks like can number 5, and it's with 1.5 meters length. No, it's 1,250. That's the length, and the longitudinal building line orientation is okay. And for can number 8, shell 8, let's make it looks like can 5. So from here, it's 150, and the longitudinal building line orientation will be 197, and click on update. And now let's click on save. Now let's add the last element, which is the top head, and we will make it looks like the bottom head, and click on save. And the only thing we will do here, which is removing the flip direction to make the direction of the head on the correct side. Now let's click on run the assembly to start creating the second can, which include 3 shell pieces, shell plates, 3 plates, as we defined on the SEG software. Okay, as you can see here, we have the assembly for all cans. After that, on that part, we will define the skirt parts, and inshallah on the next parts we will define the nozzles on the shell. And as you can see, if we take a look here on the general arrangement drawing, we have a tilted nozzle here, we have a manhole with davit as a horizontal nozzle, we have another nozzles with supports. So how to define those supports on SEG software? We have a top head nozzles, so we will need to define the top head nozzles, and one of them with a top davit. So we will learn on the second part of this video how to add those nozzles on the bottom head, and how to make the saddle nozzle vents or skirt vents, nozzle opening and skirt access, and how to add an external item like the earthing plug. But on the first part we will discuss how to generate the main items and the support skirt. Now the can number 7, we have one more can, which is can number 8, which is shell 8. After that, the top head will be generated. Okay, now as you can see, all cans generated and assembled automatically. Now the last step, which is the top head, as you can see, it's generated from segments, and each segment of those is a separate part. You can deal with it and get the weight of each segment if you would like, get the surface area for each part. Now you have a 3D CAD model, you can deal with it. Now we have the complete vessel, as you can see. Now let's add the skirt on the bottom head. So let's select the bottom head, and from elements you can figure that you have a list of elements you can add it to the bottom head. Let's select the skirt and define the name of this element as a skirt. And from here you will find 2 types. The first type is a shell from plate, and the second one the shell from pipe. Let's select shell from plate to define the inside diameter. Let's keep the values as they are, and the thickness. The thickness of the skirt is 24 millimeters. Let's check the drawing here. The skirt main thickness is 24, and here we have 3 cans. The first can here with stainless steel material and with the thickness 22, or the other cans with different thicknesses. as 24 and with a different lengths. So how to add those cans to SEG, and one more thing, which is how to define the longitudinal welding line orientation per each can. Okay, now let's come back to SEG and fill those values. Here, the first longitudinal welding line orientation on the bottom can, the last one here, it's at 24, and the total length of this can is 5 meters. Let's take a look to the drawing here. The total length of this can from the tan line to the bottom of the base plate, it's 5 meters. So the total length is 5 meters, and here the gap, let's keep it 2. And for the material, let's take a copy from this material. Let's take a copy and paste it here. And the number of longitudinal welding lines per that sheet, if we take a look, we have 2 longitudinal welding lines on that can. So let's define them as 2. And for the the first skirt plate, we need to select this part, and from here we will need to define the material of that one. So we will take that material, okay, define that one, and the length, as we can see, it's 1 meter. So let's define it as 1 meter. And from here, the longitudinal welding line orientation for this can, we can check it from here. So it's at SLS 103. So let's come back here. SLS. So we may assume it at let's assume it at let's say 45 right now, and the blade thickness of this can is 22. It's not 24. So if we come back here to check, the thickness is it's 22. So we will need to define the thickness of this one, and here we have 3 longitudinal welding lines. And from here, let's select another skirt, and from here let's define the material of the second part. So that's the material of this one, and the length of this can is 1450, and the longitudinal welding line orientation, let's assume it on 90 degree, for example, right now, and we could modify it after that. And the thickness is 24, and the number of longitudinal welding line orientation is 2. We have 2 longitudinal welding line orientation. Okay, now let's add the dimensions of the base ring. Okay, the base ring inside diameter, if we take a look to that detail, we can get the inside diameter and outside diameter and whole circle diameter from this view. So let's define the inside diameter of the base ring, the outside diameter, and here that's the thickness of the base plate, it's 50 millimeters, and the bolt circle diameter is 4168, and the hole diameter it's 99, and the number of holes, so let's take a look to the number of bolts per quarter. So it's 1, 2, 3, 4, 5, 6, 8, 9. We have 9 bolts per quarter, so it's 36. So let's add here's the number of bolts like that, and the material of the base ring, let's select the same material here. Okay, and if you would like to add a pipe sleeve, you can add it from here. Now let's add a support ribs. So from here, the rib spacing is 135. If we take a look to that detail, sorry, here that's the detail. Okay, so that's the spacing, and the bottom width is 210, and the height is 310, and the bottom width is the same of the bottom width, and the rib thickness is 20. And let's change that material, and we have a top ring, so the radial width is the same, and the hole diameter is 99, and here's the blade thickness of the top plate is 40 millimeters, and here the material of that one. Now let's add a tailing lug. So from here, let's add the tailing lug, give it the same material, and the top width of the tailing lug is 300. And for the that's the bottom width, and same for the top width, and the lug height is the same of the spacing between the top and the bottom ring. And here the lug thickness is 40 millimeters, and the lug angle is on 90 degrees, and the radius is 155, and the hole diameter is 75, and the hole offset on the half thickness 155, and the hole offset from the end it's on from the end it's 155, but that value will be 300, like that. And actually we have two tailing lugs. Now we can define the spacing between them as 710, and if we have a cooler as per this drawing, we have cooler here around this lifting lug, so we will add it. So the inside diameter of the cooler, let's change the material, and the inside diameter will be the same inside diameter of the bin hole, and the cooler outside diameter 160, and the thickness, let's make it let's say 16 millimeters. Okay, and click on save. And if you have a bracing beam, you can add a bracing beam from here. So, but the available shape here is hot roll the section as HEA or IBE, not a pipe. Here on that model, you can figure that it's a pipe, not an HEA or an HEB or I section or H section. So that configuration, we can make it manually by using the features of Autodesk Inventor. Okay, so let's remove that one and click on save. Now let's click on start assembly to start creating the skirt components and assemble it to the final assembly of the vessel. Here that's the first or the bottom can on the skirt, which include, as you can see, two longitudinal welding lines, and here that's the base plate with the holes, and we will make a modification on the hole of the base ring to make it as a slot hole, not a direct or a straight hole. Something like that you can do, make it easily, but let's finish the assembly of the skirt. Here that's the top can, and here the intermediate can. As you can see, we have two longitudinal welding lines on the mid can, but the top one we have 3 cans. Finally, we will generate the lifting lug with the defined spacing here. Now we have the skirt. If we take a look, we have the skirt with a 3 longitudinal welding line orientation on the first can, and for the second and third can it will be like that. And here we have, as you can see, we have the tailing lugs will be like that. Okay, now let's go to another part, which is modifying the base ring. So let's open the skirt and make a little bit modification on the bottom ring. Let's open it here, and if you take a look, you can figure that the bottom plate include a slot hole. It's not a direct hole, so we need to make a modification on that directly. So let's keep that pattern like that, and from here let's make a modification and project this one, and from the slot holes let's select a hole like that. Okay, and let's make that hole equals that one, and finally we will make that line cross along that one. And as you can see here, the orientation of this one will take as the same orientation of that one. Now the last thing, we will make that diameter equals that one and define the length of this one to be, let's make it 100 millimeters, for example, or make it a little bit longer, sorry, 150, like that. And finally, let's click on extrude cut. So let's make it extrude cut on the two sides through all. So the hole will be like that. Now let's select that one, and during selecting the pattern, let's select the extrude feature, and now we have the base ring will be cut like that. Okay, as you can see, we make that modification. Now we have one more item. Let's add it to the skirt, which is the top washer, and inshallah we can continue with the next part by adding the washer to the skirt and adding the as mentioned the earthing plug to the skirt. After adding the nozzles, we can make the skirt vents, skirt opening, and skirt access. Okay, thank you for your time, and inshallah waiting for you on the second part of this tutorial video. Have a nice day.